Welcome back. So we'll look at significant figures next, but before we do, we'll look at this centimeter ruler. And as we can see, we have 1 centimeter, 2 centimeters, so it goes up. Each of these marks here represents 0.1, so 1.0, 1.1, 1.2, etc. So if we were to measure this stick or rod, everyone would likely be in agreement that it is at least 1 centimeter. Okay, we could likely go even further than that. As we can see here, here's 1.1, 1.2, and if we take a look here, it's a little bit bigger than 1.2, definitely less than 1.3. So we'd likely be in agreement that it's at least 1, and that's at least 1.2. Now this last digit is where we kind of have to guess. So here's kind of like the halfway point. So we can see it's less than halfway. It may be half of the half. So you could maybe say that it's maybe 1.23. Or maybe some people would say it's 1.22 centimeters. Someone may even say 1.21. Needless to say, we all agree on the first digit, but we're guessing on the last digit. So we would say that this measurement, whichever one I pick, has 3 significant figures. 2 that we know for certain, plus 1 guess one or 1 uncertain digit. So if you can find this page, Appendix B, significant figures. So significant figures, as we saw with that ruler example, include all certain digits. And by certain digits, we mean ones that are agreed upon. So all those digits that we agree upon, plus 1 uncertain digit. Or we could say estimated guess. So the one that we had to guess on. So that would be the last digit that we include. So if we take a look, there are around 5 rules that we need to know for significant digits. So the first one is that all non-zero digits are significant. So for example, in a number like 334 centimeters, by looking at that measurement, we can tell that everyone agreed upon the 3 in the hundreds place, the 3 in the tens place, but the last digit there would have to be a guess. So the last digit is always a guess. So 1, 2, 3, we have 3 sig figs. This next one, we know that all of these digits are known for sure except the last digit. It is the guessed digit, but we still include it. So as we can see, that's 5 significant figures. And the last one here, 1.978. The last digit again is a guess, so there's 4 significant figures. So that's the easiest rule out of all of them. All non-zero digits count, they're all significant. All of them are known for certain except the last one. The next rule, if we have zeros in between non-zeros, sometimes we use the term zeros sandwiched in between, they are significant. So 203, again, the last digit is a guess. So this particular example, 3 sig figs. 400.5, 4 sig figs. 1, 2, 3, 4, with that last one being a guess. And this one, 100.0208. So that's 1, 2, 3, 4, 5, 6, and the 7th one is a guess, so 7 sig figs. So the first 2 rules, fairly straightforward. Rule 3, zeros to the left are not significant. We could say that these are placeholder zeros. So they're placeholder zeros. They're just there to ensure that our first digit is in the right spot. So here, this 0 doesn't count. But as soon as I hit my non-zero digit, yes, that counts, that counts. And of course, my last digit is a guess. So that is a total of 3 sig figs for that example. Here, 0.000. So none of those zeros count. They're just there to ensure that this 8 is in the 10,000ths place And of course we have our guess digit. So that's a total of 2 sig figs. And over here, going from left to right, in all of these, that 0 doesn't count. 9, 0, 5, 3 sig figs. Now, the last two rules tend to be a little tricky. They have to do with numbers that end in 0. So we'll look at rule 4 here. Zeros to the right of the last 0 and to the right of the decimal point are significant. So we can say that if the number ends in 0 and if the 0 is to the right of the decimal, it is significant. So if you take a look here, 89.000. So as we can see, it ends in 0. That 0 is to the right. So guess what? It must count, because otherwise, why wouldn't we have just written the number as 89? So there must be a reason why we have so many zeros there, and that's due to our measuring instrument. So that means that that ending 0 is significant, plus all of the other ones attached to it. So it's still our guess number with all the other numbers known for sure. So that particular example would have 1, 2, 3, 4, 5. Over here, it ends in 0. That 0 is to the right of the decimal, so it counts. Oh, we also have a little bit of rule number 3 here. 0, 0, 0. So those are just placeholders. So the 1 counts, the 8 counts, the 0 being our guess number, it counts 3 sig figs. And this last one, 800.00. It ends in 0. That 0 is to the right. Therefore, it's significant, plus all the other ones. 1, 2, 3, 4, 5. 5 sig figs. And the last rule. Zeros to the right of the last non-zero, but to the left of the decimal point may or may not be significant. Let's just shorten this up a little bit. Let's say it, so going off with this one said, it ends in 0, and if 0 is to the left of the decimal, it does not count unless it is stated that it does count. So let's take a look at that. So here I have 20,000 centigrams. Now that's actually a comma, not a decimal. So as we can see, it ends in 0, and we know that the decimal here is after the 0, so it's to the left. Thing is, that does not count. So here, ending zeros are placeholders. So they are there to ensure that this 2 is in the 10,000s place. So that doesn't count, that doesn't count, that doesn't count, that doesn't count. We have just 1 sig fig here, and it's a big guessed number. Over here in number 140, it ends in 0, but that 0 is to the left of the decimal. So again, it's a placeholder. Just the 1 and the 4 count, the 4 being the guessed digit. So that is only 2 sig figs. So if you wanted to, let's say we had the number 580, kind of leading to what we have down here. It ends in 0. That 0 is to the left of the decimal, therefore it doesn't count. So we have 2 sig figs there. But let's say our measuring instrument required us to keep that 0 as a significant figure. There's a few ways that we could say that this counts, and the 0 is actually a guessed number with 3 sig figs. We can show that in 3 different ways. We can put a decimal after. So that indicates that, oh, the decimal means include that 0 before. Also, what we could have done is put a line over the 0. That indicates that whatever's below it counts. So like over here, 3 sigs here, 1, 2, 3, 4 sig figs. So the line indicates the ending significant digit. And of course, the final way would be to put it in scientific notation. purposely writing that 0 down. So 5.8, the original number is 580, so that's 2 places to the right. And of course, what we're doing by putting that in scientific notation is forcing it to be a rule number 4, ending in 0, and that 0 is to the right of the decimal, so it does count. All right? So those are the main rules for significant digits. So if you turn to the assignment, we could run through a couple of them. So if you can find this assignment, you'll see examples here. So for example, here 967,000, it ends in 0, but that 0 is to the left. So guess what? It doesn't count, doesn't count. Boom, boom, guess. 3 sig figs. And then compare that to this question here, number 6. It ends in 0, but the 0 is to the right. So that 0 does count. It's my last significant digit. It's my guess number. So in this case, there are 5 sig figs. Okay, another one here, 90. It ends in 0, but that 0 is to the left, so it doesn't count. I just have 1 sig fig, and that 1 sig fig is my guess number. So run through this page, and then you can check your answers. But if you get through all 60 of these, there's some that are just one of the sig fig rules. Some numbers have all the sig fig rules combined. So go ahead, try that, and then see how you do. And we'll see you again.